All right, the reason why the adding and subtracting of rational functions is more difficult than the multiplying and dividing is because if you want to multiply 2/3 times 5/7, I don't know, what do? You just multiply the top and the bottom. You go 2 times 5 is 10, 3 times 7 is 21, and you're done, right? However, if you want to add 2/3 and 5/7, then you have to get a common denominator, okay? And so adding and subtracting fractions is always a little bit more challenging than multiplying and dividing because of that extra added step. Now, if we were to get a common denominator here, what would it be? 21, because 3 times 7 is 21, right? So you go 7 times 3 is 21, 7 times 2 is 14, 3 times 7 is 21, and 3 times 5 is 15. Right?
Okay, can we...
Okay, that's not supposed to be difficult.
That's not difficult, but I got an option.
Okay, when you're getting a common denominator, you multiply the bottom two numbers together, right? So since I had to multiply 3 by 7 to get 21, I also have to multiply the 2 by 7, which gives me 14. Okay? Since I had to multiply the 7 by 3 to get 21, I have to multiply the 5 times 3, which gives me 15. Now that was supposed to be the easy part. The key here is when I add these together, what do I get?
Just add the top.
I just add the tops. I do not add the bottom. Okay? So as a refresher, because now when we're doing this with rational expressions, it's the same process. It's just with x's in there instead. Okay? So watch for this. Think about this as we're going through and doing the adding and subtracting. Okay? So let's add together x over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. Okay? All right, and so what I'm going to do with this first is I have to find a common denominator, right? Okay. I could just multiply them together, right? But do you recognize that sometimes you don't have to do that? For example, if I was adding 1/6 plus 3/4, would the common denominator be 24? No, it would be 12, right? And the reason for that is, I know you probably never thought about this when you've done these before, but 6 is 3 times 2. 4 is 2 times 2. So since they both already have a 2 in there, I only have to multiply this by 3 to get a 3 on there, and I have to multiply that by 2 so that all these factors match up. So that's why it's 12 and not 24, okay? The same thing is true when we're doing rational expressions. So I'm going to factor this out first. Okay? What do I get when I factor it out? X and x. I need two numbers that multiply together to be 2. Okay, so subtract 2, subtract 1. So if you look at these two fractions now, what is my common denominator going to be?
X minus 1.
No.
Didn't think so.
Well, way to say something that you didn't think the answer was.
X plus y is not.
It's going to be x minus 1 times x minus 2. Okay?
So then you have to try this with top.
Yeah. So, what do I have to multiply the x minus 1 by to get x minus 1 times x minus 2? What did I have to multiply this by to get this common denominator?
X minus 2.
X minus 2. So since I multiplied the bottom by that, I have to also multiply the top by that. Okay? Because think about it. If I just looked at this fraction all by itself, I could cancel the x minus 2's, right?
Yeah.
And what would I be left with?
That's
The thing that I started with, x over x minus 1.
Did
Okay?
you get the
Oh, where did I get that?
Yeah.
Oh, okay. I got that
You
because
factored the
this has an x minus 2 and an x minus 1.
Yes.
So for this to match that, I need to toss an x minus 2 on there, and then they're the same.
So then does the top one on the other one not change?
Exactly correct.
So how come the bottom one on the second fraction is opposite of what you got like after?
Just because that's the way I happen to say it out
We're
loud.
gonna do more of these, right?
It doesn't matter. X minus 2 times x minus 1 is the same as x minus 1 times x minus 2. Yes. What?
The x times x minus.
Well, I knew that I needed to take this bottom one and multiply it by x minus 2 so it would match this, right?
So we just leave the top one.
What do you mean you guess?
I don't know why.
What do you mean you don't know why? If I want this thing right here to be the same as this right here,
OMG,
I
I got
have to
that.
multiply it by x minus 2, right? And then they would match.
Is that why X minus two?
Hold on. I know, but I'm trying to get you there. Do you understand why I have to multiply the bottom by x minus 2 to get them to match? Yes. So since I had to multiply the bottom by x minus 2, I have to multiply the top by the same thing. Okay? Okay, so now we have a common denominator. So I can write this, and remember when you add the fractions, do I change the denominator? No. So my final answer is going to still be x minus 1 over x minus 2. Okay? And then it is going to be times, what? Eh? Times, what do I do with these things here? Add them together. Okay.
It's an x minus so 2x.
Squared minus 1.
Yeah, that's what I'm trying to get at here. So what I'm hesitating for is because I have to distribute this before I add it. Okay, so x times x minus 2 is really x squared minus 2x. The reason that I distributed that first is because if I go x squared minus 2x plus 2x minus 1, what happens to the minus 2x and the plus 2x? They cancel. So really what I get on the top of here is x squared minus 1. But
Stop. We're done.
But if you factor that.
I can factor that.
Shut up.
Is that
It's x plus 1 and x minus 1 because it's a difference
Okay,
of 2
good.
squares.
Since the top is just the difference of 2 squares, I can factor the x squared minus 1 into x plus 1 times x minus 1. So those will cancel, and now I'm left with x plus 1 over x minus 2.
That was not
Katie?
I don't understand why you can't just add the top two squares, so 2x squared, and then you minus 2.
I don't see a 2x. Where's the 2x
The one
squared?
you counted.
Oh, because negative 2x plus 2x, they cancel each other.
No.
Okay. All right, we're going to play again?
Yeah.
Yes.
All right, be better. Are you ready?
Alright, so.
Okay, so let's go around again.
Wait, one second. Factor out.
Okay, so the x minus 1 cannot be factored. The x squared minus x can be factored into x times x minus 1. So there is our clue into what our common denominator would be. This has an x minus 1 and this has an x minus 1, so those pieces match. This one has an x, however, and this one does not. So that means I'm going to toss an x onto there. But if I toss an x onto there, I better toss an x onto there also. Okay? What? As long as I do the same thing to the top and the bottom, I'm okay. Just like if I do the same thing to the left side and the right side of the equation, I'm all right.
The same. Okay.
Okay, so let's do this now right off the bat. X times x plus 1 is really x squared plus x, and then over here I have a minus 2. So when I combine these, I get x squared plus x minus 2 over x times x minus 1. Nope. Because what can I can factor the top. X and x. X plus 2
Plus 2.
minus 1. And And so that means the
Cancel, cancel.
x minus 1's cancel.
Plus 2 over x, 2 over x.
Okay?
That one wasn't too
A
bad.
little bit better that time? No, because this is division and this is addition, and those aren't equal to those, so I can't cancel that. What?
So why didn't you?
Like, why don't I cancel those right there? Because division only cancels with multiplication. So for me to cancel the x's, it would have to be 2 times x over x. Then they would cancel. But since it's 2 plus x divided by x, no.
How are we ever gonna get it?
Wait, back.
Where what?
How are we gonna get it wrong cancel?
Or what?
The x's. Yeah, like that.
Wait, what? So you can just multiply the x times the 2 and the
Alicia?
When I graduate and have a family and stuff, how will I use this?
You have a family, what?
I use this almost every day in my.
That's not very useful.
Wow, you're a math teacher.
Hey.
No, I mean at home with my family.
Like
Like yesterday, I was doing the dishes after dinner, and I was trying to figure out what the best way to arrange all the dishes in there. And so I sat down at the kitchen table and I wrote up a couple of rational functions to model it. And then unfortunately, since there were so many cups and not very many spoons, I had to do some factoring and canceling. And I was able to make it work.
Two different responses.
Forrest?
I think that's geometry, and I already.
On the last two problems, you just take 2 and times it by x. Plus.
This is something
So wait, the answer is x plus 2.
over x. Yeah. Yeah, Katie, what's your question?
When on the last page, you know how you have to add the top fractions and then you do return. How do you go? I'm sorry.
What sum is that?
Okay, where you got x squared plus x.
Yeah, minus
How do you
2.
get the plus x?
Oh, because I distributed this x right here to both of these there. So x times x is x squared, and x times 1 is,
1x.
okay?
So, but if it was 2,
If it was x times x plus 2,
yeah.
then it would be x squared plus 2x. Okay? All right, one last one, since you're getting the hang of it a little bit right now. X squared minus 4 factors into,
X.
okay, so if I'm going to get a common denominator,
You need to add x minus.
You have to times it by.
this one's already good, because it's got an x minus 2 and an x plus 2, but this one only has an x plus 2, so it needs a
X
x
minus 2.
minus 2 so that they match. So if you put an x minus 2 on the bottom,
Gotta put it on
I
top.
better put one on top also. So that leaves me with x over x minus 2 times x plus 2 on the left, plus, now I'm distributing a 1, so that's easy.
1x minus 2.
1 times x is just x, and then, right, x times minus 2 is minus 2, and that's also going to be x minus 2 times x plus 2. Okay? Right, so now x plus x is 2x, oh, not x squared,
Oh, it's not multiplication.
because it's not multiplication.
How do you add them? Oh, there's the same thing.
And then I can, out of the top, I can factor out a 2, but will that cancel with anything?
No.
Nope, some doesn't.
So you have to do factoring.
Yeah. Always factor before you cancel. I should have a t-shirt that says that. Katie?
Where do you get the 2x minus 2?
The 2x minus 2? X plus x is 2x, and then minus 2 is all by itself.
Wait, why?
So just combining like terms on the top of the fraction.
Why would it be x squared?
Because x squared is x times x, but we're going plus.
That's
Okay?
why it's not multiplication.
Right. Michaela? Okay, you good?
No.
What, bud?